Many times the techniques of algebra can seem like mindless moving of symbols from here to there without any obvious purpose. In this Common Core, we're going to seek to challenge you to do mindful manipulations. In other words, always have a reason for the manipulation you are doing. A mindful manipulation will be an algebraic technique applied with a purpose in mind, even if we are unsure if the manipulation will result in success. In this sense, we want to give ourselves permission to do manipulations even if they fail to reach our purpose. So we're going to do some problems that are like solving puzzles, but we will start with a problem that illustrates the idea. So we're going to start with the expressions 2x plus 1 and 6x plus 3. So find the value of both of them when x equals 2. So that means we're going to plug 2 in for every x. So 2 times 2 plus 1 is our first expression, and our second expression is 6 times 2 plus 3. 2 times 2 is 4. 4 plus 1 is 5. 6 times 2 is 12. 12 plus 2 is 14. So what is the ratio of the larger outcome to the smaller? Why did the ratio turn out this way? What property can you use to justify this? I do have to actually apologize because this was a 3. It was my terrible writing. So it's actually 15. My bad. So the ratio of the larger outcome. The larger outcome is 15 and the smaller outcome is 5. So you can always take a ratio and you can turn it into a fraction. It does not have to be written with a colon in between them. So this is the same thing as 15 divided by 5, which is 3 over 1. So the ratio is 3 to 1. So the larger is 3 times the smaller. One of the properties you can use to justify this would be the distributive property, that 3 times the smaller will equal the larger, because 3 times 2x is 6x, and 3 times 1 is 3, so it becomes 6x plus 3, so we can use the distributive property. Okay, now for some problems that are a bit more challenging. We're going to be asked for the value of an expression without knowing the value of x, so let's do a warm-up. The expression 3x plus 2 is equal to 7. For some value of x, don't solve for it. Determine the values of each of the following expressions for the same value of x. Show your reasoning. So we're going to look at 3x plus 2 versus 6x plus 4. So we need to know, what does this become if we know that that is equal to 7? So 6x plus 4 is equal to, let's say, 2 times, because you'll notice 6 times 2 is, 6 divided by 2 is 3, and 4 divided by 2 is 2. So 2 times 3x plus 2. So these are the same, this problem, 6x plus 4, has just doubled the original problem. But we know that 3x plus 2 is equal to 7. So this is going to be 2 times 7. So 6x plus 4 is going to be equal to 2 times 7, which is going to be 14. All it's asking is, it's not asking you to find what x equals, it's asking what is this expression going to be equal to. So 6x plus 4 is going to be equal to 14. All right, and this one is going to be 3x plus 2. So we're going to have to mindfully manipulate this a little bit, just like that word that we learned at the beginning of this lesson, where we got to figure out, how do I get 3x plus 5 to be the same as 3x plus 2? Well, we know that the 3x is the same. So, oh, I didn't realize that I put 12 instead of 2. My bad. This is a 2. So how do I get from 5 to 2? Well, that's by adding. So it's going to be plus 2 plus 3. Notice that I just took the 2 plus 3 to make the 5. So now looking at this, this is the same thing as, so 3x plus 5 is now the same thing as 3x plus 2, which was our original, plus 3. So we use the associative property for that. Now we know that this is 7. We add 3 to that, so it equals 10. So this equation, the original equation, is now the same as 10. So these next ones, we're going to do the same thing. We're not finding what x equals. We're just trying to figure out what the expression could be equal to. We know that 2x plus 5 is equal to 10. So looking at letter A, 4x plus 10, what does that have in common with 2x plus 5? You might notice that it's actually double. So it is times 2. So 4x plus 10 is the same thing as double our original equation, because 2 times 2x is 4x, and 2 times 5 is 10. We know that this expression, 2x plus 5, is equal to 10. So the expression 4x plus 10 is equal to 20. Letter B, we have 2x plus 20. You will notice that our original equation was 2x plus 5. So they already have the 2x in common. It is the constant we need to change. So we need to figure out 5 plus what equals 20? Well, it's 15. So I know that 2x plus 5 plus 15 will be equivalent to 2x plus 20. Well, 2x plus 5 is 10. So 10 plus 15 is 25. Letter C, 2x plus 1. So I have 2x plus 1 is equal to 2x plus, well, the 2x is the same, we have to change the constant. Well, I need to get 5 to 1, so I have to subtract 4. Well, I know that 2x plus 5 is the same as 10. Now I need to subtract 4 from that. So 6 is what that equation or expression is equal to. The next problem is negative 2x minus 5. You might notice that there is a negative number in each one. So to get the 2x and the 5 are the same, but they've both been multiplied by negative 1. So negative 1 times 2x plus 5, well, that's going to be negative 1 times 10, because 2x plus 5 is the same as 10. So negative 10 is what that expression is equal to. To get from 2x to 10x, it's multiplying by 5. To get from 5 to 25, it's multiplying by 5. So 5 times 2x plus 5 is the same thing as 10x plus 25. We know that 2x plus 5 is the same as 10. So 50 is what that expression is equal to. And finally, I have 2x minus 5. Well, 2x plus 5 needs to become 2x minus 5, so I'm going to have to subtract 10 to get to negative 5. So 2x plus 5 minus 10, well, 10 minus 10, so 0 is what 2x minus 5 is equivalent to. So now we need to find the value of 6x plus 20. Just try to come close and see what else you have to do in terms of adding or subtracting. So I really, really, really want to encourage you to pause here and see if you can figure out this one on your own. So we need 6x plus 20 to become 2x plus 5. Well, I know that I need to multiply in order to get from 2x to 6x, so I have to multiply by 3. So I do have to multiply both sides by 3. Well, that will get me to 6x plus 15. So now, what do I have to add to the 15 to get to 20? Well, I have to add 5. So now, my original problem to get from 2x plus 5 to 6x plus 20, I have to multiply by 3 and then add 5. So 2x plus 5 is 10, multiply by 3 and add 5. Well, 3 times 10 is 30 plus 5 is 35. That took some serious manipulation, but I think that once you start to do it more and more, you will get the hang of how to actually manipulate numbers to become what you need them to be. This last question is pretty hard too. So if the expression 3x minus 4 has a value of negative 3 for some value of x, then what is the value of the expression 3x minus 4 squared plus 6x minus 8? Well, all you really need to do is we need to look at the fact that 3x minus 4 is our original equation. So negative 3 is the same as 3x minus 4. We're going to square that. And then we have to look at 6x minus 8. So how does 3x minus 4 relate to 6x minus 8? Well, 6x minus 8 is the same thing as 2 times 3x minus 4. And I know that 3x minus 4 is negative 3. So I'm going to bring down my original of negative 3 squared, and I'm going to add that. Negative 3 squared is positive 9. 2 times negative 3 is negative 6. So the answer is 3.